So welcome dear students, we'll be doing this name reaction today, Vilsmeier Haack reaction, whereby active aromatic substrates, they are converted into formyl compounds. These aromatic substrates can be activated further by electron donating groups. And how this happens is in the presence of dimethyl formamide and POCl3 and later an aqueous workup, that is H2O, and we get our formyl derivative. These reactions are important because they have been used and are continuously being used in the synthesis of important bioactive molecules, which have great implications as far as their uses are concerned, because they are pharmacologically active as medicinal compounds, synthesis of various types of other natural products which play an important role. Now, seeing to this, let's move on as to how this reaction will therefore proceed. Here I've just shown a few activated substrates. It can be benzene or activated by electron donating groups such as methoxy or isocinol by two OHs. So such substrates can be taken electron rich. At the same time, we can take N-dimethyl formamide, DMF. This is generally used, but N-methyl formanilide can be also be used, where when CH3 is substituted for a C6H5 phenyl ring. So N-methyl formanilide can also be used, though the generally DMF is the preferred amide which is used. Now POCl3 is used for creation or generation of our active species, we will see, which is required. Phosphoryl trichloride, this is used. So let's see as to how the mechanism proceeds. Now, this I've shown the simplest, that is taking benzene, electron rich, pi rich ring in the presence of POCl3 and DMF, and later on a workup with water gives rise to benzaldehyde. Formylation has taken place. Now, seeing to the mechanism as to how this mechanism proceeds. So this is now dimethyl formamide with the lone pair of electrons and POCl3 having three strongly minus I groups attracting the electron pair towards itself. So Cl, three of them are there. Cl is continuously pulling electrons so as to leave in the form of Cl negative. This will be facilitated how? When nitrogen donates its electron towards this carbon, because this carbon too is slightly positive because it's attached to, it's a carbonyl carbon, so electromeric shift O negative, C positive. So this bond will be shared here. This will become N double bond C. And this O negative can therefore give electrons to P, thereby forming this compound where CH3 and sharing its lone pair of electrons with the carbon, hence a double bond, and the carbonyl carbon O negative forming a bond with P because the Cl has now left in the form of Cl negative. Now this intermediate is formed which can react. How this will react? Because see, now Cl negative is here. Now nitrogen is having a positive charge, not a very suitable condition. So Cl negative will therefore give these, share these, form a bond here with this carbon. Why? So that the positive charge no longer remains. Now, but what will happen? Now, when this attacks here, there's a hydrogen 2 over here. The better option will be that this oxygen, because this is in the sixth group, this is in the fifth. So once Cl has formed a bond here, this oxygen, which is continuously being pulled, rather than this charge being dispelled, what will happen? This oxygen will leave as O negative. Why? Because phosphorus attached to these two Cl, attached to this double bond oxygen. This entire group is facilitating or pulling electrons from this and this oxygen. And this oxygen can therefore, this entire group can leave, that is PO2, Cl2. In place of that, a Cl we will get here. Okay, so what will happen because of this? Because of this, we will get CH3, CH3, N, CH, double bond CH, and Cl. Now this can leave, this entire entity can leave, PO2, Cl2. So we have PO2 because oxygen has pulled its electron pair, Cl2, and CH3, CH3, and double bond C, ClH. And this imine is known as the Vilsmeier reagent. So we have generated the Vilsmeier reagent. How was this generated? This was generated by the reaction of dimethyl formamide with POCl3 because the electron pair of nitrogen was shared with the carbon of dimethyl formamide. So the oxygen was therefore removed from it to form PO2Cl2, and for this the Cl negative which was removed from POCl3 was attached to carbon double bond, nitrogen double bond carbon, the carbon having the double bond as CCl. So we have got a chloroiminium ion. This has been formed, and this is the active reagent because nitrogen is having a positive charge. So this is the active reagent known as the Vilsmeier reagent. Now this Vilsmeier reagent, we have generated we have generated an electrophile. This electrophile, now the reaction will proceed as the electrophilic substitution reactions do. This will attack the benzene ring or the pi-rich, electron-rich substrate in order to give us the product. So this will, therefore, this is a benzene ring. The benzene ring, because now this charge can be the N positive over here. So now, in order to, because this, if this is removed, so this carbon will get a positive charge, isn't it? So this carbon positive will attack here in this way. So we will get now the resultant, because now it will be changed to a single bond at carbon, because now this electrophile, so it will be now carbon positive attacking this benzene ring with N, CH3, CH3, and the carbon also has Cl and H. Now what will happen? Because Cl again pulling the electrons towards itself, and how is it helped? Again by the lone pair of electrons, because once this charge moved here, the positive charge, nitrogen no longer was positively charged. The electrons were set free because it got the electrons from where? The carbon got the electrons from the pi-rich electron ring. So this lone pair was not required from nitrogen. So now nitrogen lone pairs, they facilitate or help in the elimination of Cl as Cl negative, because this is continuously pulling electrons towards itself. As a result of that, what will happen? Once again, a double bond will be formed between carbon and nitrogen. So a double bond, as it is formed between carbon and nitrogen, again, nitrogen will again get a positive charge. Now, when nitrogen gets a positive charge, the H2O workup, that is, we have added water, so that H2O, the lone pair of electrons on oxygen, will move towards nitrogen. So H2O, once it gets attached over here, then what will happen? Oxygen will develop the positive charge. So therefore this H will be pulled towards the other end. So this H from here will escape towards the nitrogen positive. So nitrogen positive here, as a result of this, is again changed to, because this carbon is no longer now carbon double bond. Carbon has got the electron pair from where? From OH. So this carbon gets the electron pair from oxygen. Which oxygen? Of water. So OH is attached to this carbon here, and this H positive is pulled by the lone pair of electrons on nitrogen, thereby generating NH, and again N will get the positive charge, because once OH2 gets attached over here, therefore H positive will leave, because this double bond will break. So the lone pair of electrons on nitrogen will come back, revert back. And these lone pairs help in pulling this H positive from H2O. So OH is attached to this carbon, and hydrogen positive is attached to nitrogen, the lone pair of nitrogen. As a result of this, nitrogen gets again a positive charge. So how can this positive charge be removed? Now, this positive charge has a very good, has become a good leaving group, because this we know will escape in the form of a neutral molecule. That is this secondary amine, N-dimethylamine. So CH3, CH3, NH, this will be the leaving group. Once this leaves, then we will get, because one bond has been broken, so carbon will get the form a double bond with the lone pair of electrons and oxygen. So now oxygen gets a positive charge, which is easily removed in the form of H positive, and we will get our derivative, that is our formyl derivative. In this case, that's why the simplest reaction, in this case, benzaldehyde. So benzaldehyde has been formed by means of Vilsmeier Haack reaction. And how did this Vilsmeier Haack reaction proceed? It proceeded with the formation of the chloroiminium ion. And how was the chloroiminium ion formed? The chloroiminium ion was formed or generated because chloroiminium ion is the electrophile which is acting on the electron rich benzene, or we can say phenyl or phenyl substrate, which have electron donating groups. It can be benzene or it can be substituted benzenes or other derivatives, but they should be aromatic and should be rich in pi electrons, because the attacking species an electrophile which is lacking electrons. So this is generated by means of the action of DMF on POCl3, whereby it is bonded to the POCl3, but one of the Cl leaves as Cl negative because it has got the electron pair from the formamide, the oxygen of the formamide. And hence that electron, now that Cl negative which is left, will attack this double bond here, carbon, so that this oxygen which is continuously pulling electrons can leave in the form of O negative. So we generate our iminium, chloroiminium ion. And this chloroiminium ion, once this bond, because this nitrogen has the positive charge, thereby that means how can this be act as the electrophile? Because this is not a stable condition. So in order to dispel this charge, what will happen? Benzene ring will attack here, so that this becomes a single bond and positive charge is removed from nitrogen. So this, after this is the general mechanism as is followed in the all our electrophilic substitution reactions, and this will therefore remove Cl. The Cl will also be removed from here, and once the Cl has been removed, we will be generating again a carbon double bond nitrogen, and this carbon double bond nitrogen, nitrogen again getting the positive charge. How is it removed? Why? Because H2O work up, OH negative attaches to this carbon, so that this nitrogen gets again becomes a single bonded with lone pair, and that lone pair attracts the other H positive. So H positive with nitrogen, OH with this carbon, and now this leaves us the neutral molecule, that is our amine, and we generate our formyl derivative or our benzaldehyde. Now here are two other examples. I could have given more, but let's see. You will again. This is what a pi-rich ring, aromatic substrate, pyrrole, in the presence of DMF and POCl3, and then reacting with water. What will we get? Pyrrole to aldehyde, because now we know the mechanism as to how it proceeds, so we won't be doing the mechanism again and again, just one or two examples to make you more familiar with our Vilsmeier Haack reaction. And this is again a substrate which is having electron donating groups, three of them, and this will again lead to this formylation CHO, because this methoxy and this is methyl. So based on that, para to this, ortho to this, these two will work together. Now let's see a problem based on this. The problem is such that first let's see what the problem is, then we will solve it. I've written this here. So the problem was basically as to what is formed when this reacts with POCl3 in the presence of C6H5 CH2NH2. Coming to this, how we solve this problem, I've just put up this little problem so that the aspect and the importance of this reaction becomes clear to you. Now we know that this NHO, see it's being given in a cyclic form this way. Earlier on it was dimethyl formamide, if you remember. So this is similar. Now what will happen? Where will this react on this NH or this? So we know POCl3 doesn't react with the NH, it reacts with the double bond O. How? Because this will share electrons, the lone pair of electrons at this position. So this O as O negative will therefore tend to form bond with POCl3, forming PO2Cl2 and leading to the elimination of Cl negative. This Cl negative will therefore then attack at this position so that we get our so-called iminium, chloroiminium ion. So that has been formed, and once this has been formed, then the reaction will proceed further as to how. Because see, we have got P, this is now POCl is a good POCl2. It is a, it will with O negative will leave, so the Cl will be coming to this position. Hence, once this has been formed, now this has a positive charge here, and we know that this is a this H over here is highly acidic, because this is positively charged, so it becomes, and moreover attached to this electronegative group, so H will be, this positive charge can be dispelled because this H will be abstracted by the PO2Cl2 O negative here. So when O negative takes this H positive, once this takes this H positive, then we get this chloropyridine, total aromatization, and we get this chloropyridine. Chloropyridine, once this has been formed, then this will react, if you recollect, as I showed, C6H5CH2NH2. This will react with this. Now till here it was okay. Now this, when this is added, this is a step further, because we know this will give a good substitution reaction, whereby this will be substituted because nitrogen is present. So it can easily be substituted over here. So we will get C6H5 and it was CH2NH2, HCl will be eliminated, and what will be formed? This compound will be formed, this derivative will be. So this was a step further. And see, it's just a variation of the reaction. It's an application of, indirect application of this Vilsmeier Haack reaction. So this has been applied because the reagents are the same, as you can see here. So because slight variation over here, because this is a cyclic structure. Earlier on we didn't do it, and moreover cyclic structure with a double bond over inserted at this position. So it's a slight change to the normal reaction, but the Vilsmeier Haack reaction rules apply. And if we work accordingly and proceed accordingly as to how, at which position, because we know this POCl3 doesn't won't react at NH. That was a catch here, because of Cl and NH that they might know. It reacts at this position so that we get, this is O. O, PO, Cl2 and Cl is eliminated from here. This Cl negative is the one, because see, now this is a ring and this is the aromatic character is being disturbed now and is getting a positive charge. So what will happen? The Cl will substitute it at this position so that this is eliminated, this entire group, PO2, Cl2. So if you recollect, this is what happens in Vilsmeier, and we get this Cl substituted product here. Once this Cl is here and this H here, the nitrogen, the positive charge, we very well know this is not a stable condition. So what will happen in the next step is that H positive will be abstracted by this PO2Cl2 and we will get a chloropyridine, and after this the normal substitution reaction with C6H5CH2 and H2 to give us this. HCl will leave, a substitution will occur and we will get this as the product. So I hope you have followed this. Let's see another example in this. Now this is a very simple example. You can please work up the mechanism of this reaction, the normal Vilsmeier reaction, and then the electrophilic substitution reaction after that, after the formation of chloroiminium salt, because this is DMF, POCl3 and H2O, so we will get anisaldehyde. So this anisaldehyde will be formed from this, and the normal electrophilic substitution reaction. So that's all for today. Good day.